For these problems, we can see that we are given a string s and an integer k. We need to return the maximum number of word letters in any substring of s with length k. So overall, the input is s, which is a string, and we also have another input, which is integer k. It is the maximum number of the integer k is the substring's length. And we need to return the maximum number of word letters in any of the substring. So we can see that these problems ask me to return the maximum number of word letters. And before I jump to the solution, I would like to look at the constraints as well. The length of a string is between 1 and 100,000. And the S contains lowercase English letters. Okay, and more we also make sure that the minimal number for key is 1. It means we do have this substring. Okay, for these problems, the asking for the maximum number of word letters give me the hint that I need to this is the variable I need to return. So in the initialize part, I need to initialize the variable and I need to return. Here I will initialize this to 0. And in addition to this, I need to have a temporary length of the maximal number of word letters. So I need another variable, which is a temp, to keep track of the intermediate maximum numbers, and then I will keep update result based on the temp. And in addition to those variables I need to initialize, I would also like to calculate the length of the string. So it will be easier for me to, use a for loop and get access each characters in the string. And overall, we can see that this problem, we can use a sliding window to keep track of the substring. So as so when we need use the sliding window, I need to initialize two pointers. One is the left, another is right. I will initialize both of them to the 0 index. And now I think I finished the initialize step, and I am going to use a for loop to keep moving the right pointer, and I need to use the right pointer to moving forward. So I can expand the window, and also I need to have another step, which is I need to shrink the window. I will talk about when should I expand the window and when should I shrink the window. For the expand window part, as long as the length of the string is less than key, we can expand the window. So the shrink window part is the less of the substring is bigger than key. So we can see that first let me access the character which the right pointer point to, and I need to check if this character is in is belong to the vowel letters or not. So here I need to add another, I need to initialize, I need to store all the vowels in a string, which is A, E, I, O, U. Okay, so here I need to check if the character is in the need string or not. If the character in the need, it means that I can update the temp. I can update the temp here. Okay. So at this time, the right pointer will keep moving forward, and the window will be expand. So when if the window, which is right minus left pointer, is bigger than key, is bigger than key, it means we need to shrink the window. At this time, I need to shrink the window and also update my result. So my result will be the max of temp and the current result. So after I update my result, I need to shrink the window as well. How can I shrink the window? I just need to move the left pointer. But before I move the left pointer, I need to I need to get the character to see if the character which left pointer point to is in need or not. If the character in need at this time, I need to reduce the number of counting for the walls in the substring, and I need to move the left pointer forward, but I also need to make sure that the left pointer is not being moved out of the range. Okay, so as long as left pointer pointed to the index before the end index, I can move the left pointer forward. So after left and right pointer iterate through all of the characters in the string, I just need to return my result. Okay, so that's all for the code. Let me see if it works. Okay, so here there's a bug here. Let me double check. It's character in need. Oh, so I don't need if character in need will be fine. Okay, so there are some logic errors. So I will double check my code and to see what's wrong here. I think here I need to include the right minus left equals key here. So let me try again. Yes, it works. Okay. And now let me explain the time and space complexity. So in regarding to the time complexity, we have 2 pointers left and right, and I use both of them iterate the string 2 times. One is through right, another one is through left. But overall, the big O time complexity is still O1. In regarding space complexity, I use the need to to store all the walls. It takes the consistent space complexity, and I also initialized a few variables to keep track of the intermediate result. For example, the temp, and I also have n to store the length of the string. But overall, it takes consistent space complexity. So we can say that the space complexity is O1. That's all for this problem.